The statement of purpose is one of the most important parts of your application to graduate school. And it's quite difficult to find high quality information on the internet, and it's also difficult to know what information out there is reliable and what's not. So today we're getting right to the core of the issue, and I'm here with Sharon Sani Sahu, and he actually applied to a lot of schools, and his statement of purpose got him into Harvard, Princeton, Cornell, Yale, Chicago, Carnegie Mellon University, and even Berkeley. And so, we're very pleased to have him on the channel today. And today, he and I are going to together talk about some tips and tricks for improving your own statement of purpose. And then we'll finish with Sani actually reading his own statement of purpose verbatim, word for word, so that you guys can have a good example to look at.
So of course the SOP is just one part of the application, but it's also one of the more highly important parts of the application that people want to kind of smooth out and make sure that everything is good to go on that end. And so what we're going to try to do is try to give you a few tips and tricks on how to write the best possible SOP, so it kind of conveys your thoughts, it's structured properly, and so you have the best chance when it comes to writing a very good SOP.
Tip number one is that you don't want to regurgitate your resume onto your statement of purpose. So in your resume, you can think of it as a bunch of kind of bullet points of what you've done. But in the statement of purpose, that's where it's time to be specific about what your actual contribution was, what the actual outcomes were from that work, and everything that you learned from that project. So we'll talk about this more a little bit as well, but you want to be as technical as possible in the statement of purpose, kind of being very specific about what you contributed and what came out of your projects and experiences. And so you don't want to just regurgitate kind of a list of facts about what you've accomplished, because that's already in the resume itself. I alluded to this in the previous tip, but tip number two is to be as technical as possible in your statement of purpose when describing what you've done, especially in research. This is especially relevant for PhD applications, or if you're doing kind of a research focused master's, maybe a master's that has a thesis in it. The reason that you want to be technical is because whenever you're writing the statement of purpose and you submit it, the committee of people who are reviewing it are professors themselves, the professors in the department that you're applying to. And so they're going to be a very technical audience to read this, and they're trying to really figure out how much do you actually know, how much did you actually contribute. And so the finer and finer details that you can give them about the work that you've done, I think that the more convincing it is for the committee, and the more favorable they'll view it for your admission into their department. Tip number three actually comes straight from the former department chair of the statistics department here at Cornell. And he's probably reviewed over, many thousands of applications at this point over his tenure. And he said that one of the main things that the committee is looking for in a statement of purpose is the resiliency of the applicant. Basically, he said that when times get difficult in research, as they often do, will it seem like this person is just going to give up and perhaps just leave? Or will they have the ability to push through? And so if you can communicate something like that about what doing a PhD or what this master's degree or graduate degree actually means to you and why you're doing it, if you have a strong why, then that can also help your application.
So tip number four that we have is understanding whether the admissions committee is going to be largely committee driven or PI driven. And when I talk about committee driven, that usually means that there's a group of professors of varying research interests that form the committee and kind of take a look at your application. They collectively decide whether you'll be admitted to the graduate school or not for your particular program. When I talk about a PI based, that usually means that there's a single PI that you apply to that takes a look at your application, determines if you would be a good fit for their lab, and then decides whether they will admit you to their lab or not and the program in general. Now, if it is largely committee driven, you have free reign to be very flexible with what you write in your SOP. So if you have multiple areas of interest or multiple things that you want to explore during your PhD, it's good to kind of write those out and detail how you would like to explore those. If it's largely PI driven, then it's better to be more focused on the areas of research of which your PI is interested in and or future directions which they want to go in. And you should outline those in the projects that you're doing or the research that you've done in the past. Number five that we have is mainly applicable if you've been out of school for a little bit and you've been working in industry for some time, and now you want to make the transition back to academia and actually doing a master's or a PhD. In those cases, what you should largely do is take the relevant industry experience that you've had and kind of frame it as how that informed you on why you want to go back and pursue a PhD or a master's degree, and kind of talk about what things you learned in industry and how you can bring that a different perspective or those different computational tool sets or whatever you learned during the job, how you can bring that to uh, your PhD program and how it can benefit the PI or the department that you work in. So tip number 6 that we have is about structuring your SOP. Now there's many different ways that you can kind of structure your SOP to communicate your ideas effectively, but we're going to give you one particular type of structure that we've seen in the past that I actually used on my SOP and that other graduate students have used who were successful into getting into multiple different graduate schools. So the first thing that we want to talk about is the length of your SOP. Now, generally what most people say is that the range of your SOP length should be around 1.5 to 2.5 pages. And now you should usually aim for somewhere between 1.5 or 2, but if you do have a lot of details to explain in your statement of purpose, it's okay to go a little bit over 2 pages. So in the introduction of your SOP, you kind of want to highlight what your domain of interest is and what vision you see for your PhD. So you can kind of detail what kinds of research areas you would want to pursue during your PhD, what types of topics you would want to pursue during your PhD, and kind of give an introduction to what your goals are for doing a PhD and why you want to pursue a PhD. In the main body of your SOP, you want to explain your previous work and how it kind of drove you to pursuing a PhD and the topic of interest that you're interested in. So this kind of should be something like a high level idea of some of the research projects that you were involved in, who you are working on those research projects with, your contributions to those research projects, and also the outcome of these research projects. And when I talk about outcome, it could be something like a conference submission, a journal submission, or maybe you weren't successful in submitting this paper or this piece of work to a journal or a conference. That's also fine. Because it's also good to highlight, running into roadblocks and how you dealt with the running into roadblocks with research. Because as we talked about resilience a lot, and so being resilient and showing that in your SOP is also very important. And so if this happens to you, it's okay. It's also a good experience to write it down. And you also want to link all of these back to how these drive your research interests and why you want to pursue a PhD. So maybe you worked on some topic, maybe you found it to be very interesting, very enlightening. Uh, you can kind of link that back to why you are persuaded to do your PhD in this topic of interest. Another thing that you can outline in your SOP is specific courses that you took and why those drove you to wanting to pursue a PhD. So, for example, let's say that you took a graduate course or an undergraduate course in a particular topic of interest. That professor really excited you and the content really excited you. You can actually detail that in your SOP as a reason for why you want to explore that topic more in depth in a PhD. Another thing that I would say is important to highlight is if you have any relevant industry experience from whether that be internships or full-time jobs, and what you learned from those. So that could be something as simple as, you learned a new piece of software that you don't think is used a lot of in academia and how you can bring that to academia. Maybe you learned a new tool set to use. But these things should also be highlighted because it kind of gives you a broader view on research and how you tackle problems in research. And that's important for your PI to know, PI that you want to work with or the committee in general. One thing that you definitely want to include in your SOP is to relate the topic of interest that you have back to faculty of the department that you want to apply to. And this is important for many reasons. Of course, it depends on, again, if it's very PI focused admissions or if it's very committee focused admissions. But at the end of the day, there needs to be a good fit between you as a PhD student and what you're interested in and the fit of the department in general. So, for example, let's say that you want to work on a particular topic of your interest, but there's no professors in that department that work on that topic, then it's kind of not a good fit, and they will kind of question why you even want to apply to this department. So, a good thing to do is also to research the people in the department that you're interested in and kind of see whether there is a good fit between you and any professors in the department, and kind of outline that in your SOP. Talk about the professors that you're interested in working with, what projects that they've worked on that have particularly piqued your interest, and further things that you can do with them. And also just highlighting maybe some of the projects that you worked on in the past and how they relate to ideas that this PI or professor actually works on. So in the conclusion of your SOP, you want to just briefly wrap up the content that you've written in your recipe. So that means you want to kind of highlight your experiences and the coursework that you've taken and why they make you a good candidate for the department and program that you are applying to. One other thing that you should do usually in the conclusion is talk about your future goals, whether that be you wanting to go into academia or industry, and kind of highlighting why the school or the department that you're applying to gives you the best path for accomplishing the goals that you want. So if you want to go into academia or you want to go into industry, kind of explain why this is the best program for you and why they will help you get to where you want to go in the future.
You know, Sunny, speaking of structure, an important part of being a PhD student or a master's student is having a very structured routine, and part of that structured routine is the ability to focus. And so I'm going to do a little transition here, and I want to talk about the sponsor of today's video, which is Decibel Defense headphones. They're the best headphone company that I've seen, and I've been using headphones. Really specifically, these are actually just earmuffs. They're not any digital technology, but the ability of focusing when you're wearing these headphones, and I've been using like the earmuffs or headphones for maybe 2 or 3 years now, and I could say that these are the best ones that I've ever tried, and I would highly recommend them. If you want to get a pair of Decibel Defense earmuffs for yourself, they've generously offered a 15% discount code if you use code SATHIJA15 when checking out at their Shopify site, which I'll put in the description below. All proceeds that this YouTube channel generates are donated to children in need in Sri Lanka. Now let's get back to the video. Now for the moment that you've been waiting for. So Sunny is going to read out loud his actual statement of purpose that got him into these awesome schools. And in the description, you'll find a Google link to a PDF file of Sunny's exact statement of purpose so that you can have a reference for when you're writing your own.
The scale and complexity of digitized high-resolution spatial omics data that pathology labs are starting to generate are tens to hundreds of thousands of pixels in dimension and take years of medical training to interpret. The capability to leverage this growing wealth of pathology data is critically dependent on the development and application of statistical machine learning methods. I'm interested in statistical machine learning, particularly high-dimensional statistics, conformal inference, and computer vision, and using statistical and machine learning tools to improve clinical decision-making and bridge the gap between machine learning methodology and clinical practice by making these methods more reliable, human-compatible, statistically rigorous, and clinically deployable. As a PhD candidate, my vision for my research would include A. Developing AI and machine learning models with a focus on developing high-dimensional statistics and conformal inference theory for practical applications. B. Solving statistical and computational challenges for complex data in biomedical fields like pathology. And C. Creating clinically deployable algorithms and open source software for clinicians, data scientists, and researchers. Finding my research interests. My time at UC Berkeley has allowed me to do research and gain insights on a wide range of topics from computational chemistry to generative modeling and reinforcement learning. One of my first research projects began under Professor A at USC. One major challenge in the current machine learning community is obtaining large labeled datasets for training. One solution is to use generative models to amplify sparse datasets by providing ground truth annotations with synthetic data. However, the key challenge is assessing how good these synthetic datasets are. To address this problem, we developed reliable and efficient model-agnostic metrics to evaluate the performance of generative models using contrastive unsupervised representation learning. This work was presented as developing multidimensional metrics for precision, recall, fidelity, diversity, and authenticity in evaluating generative network performance using deep perceptual embeddings in SPI DCS and DoD 6.122. My contributions included replicating previous state-of-the-art results, developing probabilistic and interpretable multidimensional metrics under various contrastive loss representations, and experimenting with different generative model architectures. Although I was engaged with the technical aspects of solving this open ended problem, I wanted something that would excite me, something that I could apply to create a tangible impact. I joined Professor B's computational pathology lab in my junior year, and this is where my interest in computational precision medicine emerged. As part of this lab, I have been fortunate to conduct some initial work that actively contributes towards the goals I envisioned for my PhD. Multitask learning for cell segmentation using mixed annotations. A key bottleneck in computational pathology is the time and cost associated with acquiring a large number of expert annotations for training high performance, robust models. In collaboration with Professor B and PhD student, we aim to reduce costs for training panoptic segmentation models by developing mixed annotation training that decrease the expert time required to make annotations. Currently, we are investigating UNet and vision transformer backbones using multitask learning with multi-head and representational stitching architectures. My contributions include creating a package for analyzing segmentation results with pixel-wise and object matching segmentation metrics, and also developing multi-head and representational stitching architectures with vision transformer backbones using loss balancing techniques such as simple grid searches and gradient normalization. Our current findings illustrate that we can achieve similar performance to models trained with a large number of expert annotations. While our current focus has been using these models for cell segmentation and computational pathology, these methods generalize to all segmentation problems and can be impactful in single task and multitask networks. This work will appear soon in mixed annotation cell and nuclear segmentation model with multitask learning in NeurIPS 2024. Open source software with WSIC package. These high-resolution images of tissue are quite large and take up a couple of gigabytes in memory. Additionally, running segmentation algorithms on these large whole slide images is not straightforward. In collaboration with Professor B, we develop an open source software package called WSIC to facilitate running cell and nuclear segmentation algorithms on WSIs, or whole slide images, for computational applications in histopathology by breaking WSIs into smaller image patches that are segmented independently and merged with little to no boundary effects. My contributions were implementing and parallelizing various classical computer vision segmentation techniques such as gradient flow tracking and Gaussian voting, as well as deep learning segmentation techniques such as HoverNet and Stardust using distributed computing across GPUs using Ray. We aim to provide a useful tool to help data scientists by augmenting existing cell segmentation and pathology software. This work will be published soon as WSIC, a Python package to facilitate running nuclear and cellular segmentation on whole slide images in the Journal of Open Source Software in 2024. Clinical applications for IHC quantification. Immunohistochemistry, also known as IHC, is a technique used in pathology to detect specific antigens in cells of a tissue section. This method is widely used for diagnosing various types of cancer, including neuroendocrine tumors, which are also known as NEATs. Ki67 is a marker for cell proliferation in NEATs and is usually quantified using IHC staining. This naturally presents itself as an instant segmentation problem, where the goal is to distinguish between positive, which is stained distinctly, and negative Ki67 cells. Using the mixed annotation model and open source software we are currently developing, we are actively working with pathologists and clinicians to develop a clinically deployable algorithm to assess growth rate and aggressiveness of tumors for prognosis and treatment planning. Conformal inference and high-dimensional statistics. My work in clinical machine learning led me to Professor C, whose expertise and enthusiasm for high-dimensional statistics, non-parametric estimation, and distribution-free inference encouraged me to enroll in a graduate-level statistical learning theory course during my junior year. Professor C graciously invited me to join his PhD student group meetings as the only undergrad. As part of this group, I have been exposed to active research in conformal inference and high-dimensional statistics. These group discussions have given me plenty of insights into new techniques that can be used to analyze biomedical problems, ranging from tumor heterogeneity and disease progression to metastasis to digital histopathology. Relevant experience. I realized the need for a strong theoretical foundation to pursue advanced research. In this direction, I have always strived to challenge myself and grow my mathematical and computational skills by taking graduate coursework in high dimensional statistics, measure theory, differential topology, and parallel computing. Additionally, my internship experiences in the DoD as a smart scholar have allowed me to understand and address machine learning problems in the industry with technical solutions. And these were presented at conferences such as Streamlining System Requirement Classification and Clustering Through System Deep Learning and Architecture Design, which was presented in NAML 2023 and 2024, and System Requirement Clustering with Machine Learning, which was presented at Neptune ONR 2023 at Cornell. All my experiences collectively shaped my research interests and motivated me to pursue graduate studies. With an understanding of the problem space through actively solving problems and growing my technical skills, I hope to continue developing statistical machine learning theory to improve clinical decision making. Cornell's demonstrated leadership in my areas of interest, its exemplary faculty, and its unique interdisciplinary atmosphere make it the ideal environment for me to conduct my research and graduate studies. Professor D and Professor E are faculty that I would especially like to work with. Professor D's paper on imputation for high-dimensional linear regression works on an interesting problem of high-dimensional regression with missing covariate entries. Traditionally, missing entries are imputed with substitutes before applying statistical methods. This paper proposes a simpler method, filling missing entries with their conditional mean based on the observed covariates. It demonstrates that with this approach, combined with standard procedures like lasso and square root lasso, this maintains effective estimation rates in scenarios with independently and identically distributed sub-Gaussian covariates. Additionally, it addresses situations where conditional expectations are approximated from data, focusing on covariates following an autoregressive process or a jointly Gaussian distribution with a sparse precision matrix. The paper introduces practical estimators for these conditional expectations and applies them in linear regression using lasso. It would be interesting to further develop this work by considering the exact asymptotic performance of these procedures in proportional regimes rather than the high dimensional regime. Additionally, my recent interest in mean field asymptotics aligns with Professor D's recent work, and it would be extremely exciting to work with him to develop theory and applications for computational biology, such as in modeling gene regulatory networks or stochastic modeling of pathological procedures. Professor E's recent paper on SLIDE, which stands for Significant Latent Factor Interaction Discovery and Exploration Across Biological Domains, presents an innovative machine learning technique designed for the analysis of high-dimensional omics data, which are often challenging due to the differences in data modalities, multicollinearity, and the presence of numerical and numerous irrelevant features. SLIDE stands out for its ability to identify significant interacting latent factors underlying specific outcomes of interest, offering a versatile and interpretable solution without making assumptions about data generating mechanisms. It comes with theoretical guarantees for the identifiability of these latent factors, ensuring reliable inference. It'd be interesting to adapt SLIDE to handle spatial omics data to provide new insights into the spatial distribution and interactions of latent factors in various diseases. Additionally, Professor E's recent projects in optimal transport for high-dimensional mixture distributions, inference for Wasserstein distance between latent structures and topic models, are projects in high-dimensional statistical inference that I would like to explore, and it would be a great opportunity to work under her supervision on research in statistical machine learning theory and high-dimensional statistical inference. My preparation for this journey is rooted in the extensive academic exposure I've had, my mathematical and collaborative and computational skill set, my soft skills, and above all, an insatiable desire to learn and excel. Collaborating with the faculty and students at Cornell in the Department of Statistics and Data Science, I'm fully poised to harness my capabilities, and I'm driven by the ambition to one day assume a faculty position at a leading research university, making contributions to statistical machine learning, and developing methods that refine clinical decision making and bridge technical methodologies with real world medical practice.
So yeah, thanks so much for watching, and hopefully you're able to get something out of this video and hearing Sunny's SOP. Also, make sure to check out this video if you want to hear my own statement of purpose that got me into this department, which is Cornell Statistics. And yeah, I hope that you're able to get something out of it. And thanks so much for coming onto the channel, Sunny, and sharing your statement with us.
Yeah, it's great. I know that a bunch of you are probably applying to PhD programs now, filling out those SOPs, writing those SOPs. And so hopefully this video is really helpful, gave you some cool tips that you can also apply to your own SOP.
Yeah, and make sure to, if you have a question for us, just leave it down below. Either Sunny or I will get to it. Make sure to subscribe for more grad school related content, and I'll see you in the next one. Bye.
See you.
For more grad school related content. And so yeah, Sunny, thanks so much for coming on the channel and shooting this video today.
Yeah, thanks for having me. Greatly. No. I was gonna say greatly appreciated.